The topic that we are going to discuss right now is LLMs and prompt engineering. This is one of the hot topic that is going around in the data science community. And prompt engineering is damn easy. By the end of this session, you yourself will be feeling very confident about prompt engineering. At the end of this session, you can add a particular line on your CV saying that you have attended a workshop on prompt engineering and you're aware of the techniques that are there in prompt engineering. Let us go get started. Imagine if you have hundreds of experts who are helping you all the way in your day-to-day life. Imagine there's a friend, whenever you write a sentence in English, he is correcting all the grammar and then he's giving you or suggesting you multiple ways of writing the same sentence so that you can write in a better manner. Imagine there is a philosopher who's sitting beside you and he is offering you deep insights whenever you get confused morally or ethically. Then there's a philosopher who is helping you with that. Imagine there is an expert trainer who is helping you with all your fitness, like how to do a certain exercise. Let's say on a given day, what is exercise that you have to do? Next day, what is exercise that you have to do? What is the diet that you have to take? Imagine there are a bunch of trainers that are helping you with that all the while, who are sitting beside you, who are with you all the way. Think of an interview panelist who is taking your mock interview and giving you tips and tricks before attending any job interview. Imagine a lawyer who is explaining you basic legal concepts. Let's say you want to send a small legal notice. Imagine a lawyer who is helping you with that. Imagine a maths teacher who is helping you to simplify the tough concepts. So, whomsoever is an expert that you can think of, let's say there is a political analyst, there is a news reader. Imagine all those experts are in your pocket. They are helping you all the way around. That is nothing but an LLM. LLM is more than 100 of experts, in fact, thousands and thousands of experts who are with you all the while. So, what exactly is an LLM? LLM stands for Large Language Model. Large Language Model. Model is something like a mathematical equation which makes a prediction. Language model makes predictions about the language data and natural language. And what exactly is large language model? Let us get a better idea of that. First of all, if I ask you this question, have you ever used any language model before 5 years? Because these large language models, it is the buzz from last 2 or 3 years only. Largely from last 1.5 year, they are into this market. But before that, let's say if I take you back to 5 years, have you ever used any language model? If we think of that, yes, we did use. 5 years back itself, we have used chatbots. We have interacted with chatbots. Those are some of the language models which will understand the user question and try to give you the answer in the form of the chat. Now, on Amazon, on Flipkart, you have the user reviews. Based on the reviews, whether this review is positive or negative, that is also an example of a language model. Now, if you are typing something on your phone, as soon as you type a couple of letters or a couple of words, automatically the next word is predicted. That is also an application of language model. So what exactly is a language model? A model that handles language data or natural language data or the text data. Those are known as language models. Or these are all typical small language models. I would not say these are large language models. These are small language models. A language model that finds the interesting patterns in the text data and helps us in predicting the summarizing or classifying of the text. What is classifying of the text given the review, whether it is positive or negative? That is one of the example of a language model. So some of the applications of the language model that are wide known even before these large language models came into the picture, taking a review as input, predicting the sentiment, predicting the next word while writing the text in our phone, finding the keywords in a given text. Somebody writes a post on LinkedIn, then suggested keywords or hashtags, or on Twitter, if you write something, suggested hashtags that we get, that is also an application of language model or a small chatbot. These are all applications of language models. You can call them as small language models or a regular normal language model. Now, what we are talking about is not the regular language model. We are talking about a large language model. So what is a large language model? Basically what it does, what is the core functionality of a large language model? At the core of it, a large language model predicts what is the next word. That's it. A large language model, the job that it does is it predicts what is the next item in the sequence. If somebody writes, oh, what a lovely, it can be, oh, what a lovely car, oh, what a lovely weather, what a lovely flower. So, oh, what a lovely car. Let's say that is a predicted value. And then these five will be taken as input. Oh, what a lovely car. There are multiple possibilities. And then it will predict I. Oh, what a lovely car. And then what can be the next word that can be predicted? And then it will predict I would. Then this all will be the input. Oh, what a lovely car. I would like to buy. Like that, it will keep on predicting. Once it hits the meaningful stopping point, Let's say after generating 50 or 60 words, once it hits the meaningful stopping point, then it will stop. That is what a large language model does. Have you ever observed when you are asking any question on ChatGPT, word by word, all these words are generated one by one, one by one. Have you observed it? It's not like the output will be given to you within one shot. One by one word, all these words are generated. And then once it hits the meaningful stopping point, then it will stop. So that is what a large language model does in the backend. It just predicts the next item in the sequence or simple words. It predicts what is the next word. But why are they called large? It is just a language model. What is the language model that handles the text data? Why are they called large language models? Because of three reasons. Large amount of data was used in building these models. Large number of parameters. These models contain large number of parameters. And these models are built by using large scale computations. So while building these models, hell lot of data was used. We can say that almost the whole internet of data, billions and billions of websites, thousands and thousands of books and literature databases, scientific articles and journals, all the billions of websites, all the blog posts, all the social media forums and discussions, all the news articles, even the dictionaries, encyclopedias, open source data sets, everything that is available on internet, complete internet data has been used. Imagine a model that has the whole information of the whole internet until now. Whatever in our human evolution, whatever is in the data form, all of that has been used for building this model. Don't you think that is a large amount of data? Usually we have gigabytes of data, petabytes of data, hexabytes of data. Now that is what the data that we are talking about here is much, much beyond that. Whatever is the whole internet of data that is available right now, all of that is used for building the model. Definitely it is large amount of data. And for building these models are very, very complex. There are large number of parameters that are used. So what is exactly a parameter? Let us suppose if you are building a credit risk model for predicting whether a customer is defaulter or a non-defaulter. For coming up with a credit score, you want to consider some of the factors. Typically, for calculating credit score, we tend to take 50 to 100 factors or the features, not more than that. 100 itself is very large. So there will be 100 parameters. So in building a credit score model, there are 100 parameters. So if you ask me what is the complexity of a credit scoring model to predict whether a customer is going to be defaulter or a bad customer or a non-defaulter, which is a good customer, this model's complexity is around 100. That means 100 parameters are there. Now, in similar terms, if we see what is the complexity of the large language models. So some of the large language models, if we take ChatGPT, the behind the scenes GPT model is used. In 2018, this we haven't even used. This is not the ChatGPT that we're talking about. One of the early versions of the ChatGPT. In 2018, 110 million parameters were used. So here we are talking about a credit risk model, 100 parameters. So in ChatGPT, it's not 1,000 parameters, it's not 10,000, it's not a million, it's not even some tens of millions, it's hundreds of million parameters. In GPT-2, 2019, 1.5 billion parameters. In GPT-3, 2020, 175 billion parameters were used, the number of parameters. So the model's complexity, how complex is a credit risk model? A model that is having 100 parameters. How complex is ChatGPT? GPT-3 onwards, that is when we started using it. It is having 175 billion parameters. So these are models that are hugely, hugely complex. The models have too many parameters. That means parameter is a way of measuring how complex the model is, and the model is quite complex. So large language models are called large because of the reasons like the large amount of data is used, large number of parameters are used in constructing these models. And then obviously, if you have such a complex model, you need large scale computations. You cannot just build these large language models on a laptop like what we are using. You cannot build these large language models on even a huge supercomputer. You need huge amount of GPU. GPU stands for graphics processing unit, or where you are using multiple parallel processors, multiple parallel processor to do all these calculations, because here we are talking about millions and billions of parameters. In fact, GPT-3 has 1.75 trillion parameters, trillions and trillion parameters to calculate them. To build a credit risk model, you can simply use a laptop. You hardly need to calculate 100 parameters, and the data is also manageable size. Maybe we will have 1,000, 10,000 records, or maybe 100,000 records, or maybe 1 million records, 1 million customers max, but not more than that. But whereas here you have the data that is the whole internet of data, you have the model that is trillions of parameters. That is the reason why to build these models, we need very large scale computations. As a simple idea, if I have to tell you how much is the cost to build a GPT model, if we think of that, the cost for building the GPT model runs around $100 million, which is nearly 820 or 850 crores as of now. So if you want to build one model, then they are talking about just the processing power. It is not really the rest of the team, etc., etc. Just for processing the powerful computational chips, etc., etc. The process costs over $100 million. That means somebody like you, single individual, can he build a large language model? It's impossible because it involves a huge costing. So those are the three reasons why these language models are known as large language models. Why are they called as large language models? What are the three reasons? The first reason is large amount of data has been used, the whole internet of data. There are large number of parameters that were involved in building these models. The third reason is there is a huge amount of large scale computations and there is a lot of costing involved in this. And what is the result? The results of these large language models are unbelievable. In the history, we have never seen, if you go before 2022, people have never thought that something like what we are seeing today can be achievable. So I have attended few of the seminars, I think somewhere around 2016. During that time, somebody has built a model on all the Donald Trump tweets, and then this model has to predict whether the Donald Trump, something like Donald Trump is tweeting based on all his speeches, based on all his tweets, based on all the available information on Donald Trump. A model was built, and then this model has to make a small tweet that looks like Donald Trump. And that itself was a huge achievement. People thought that this is wonderful, like, it is somewhat sounding like Donald Trump. In fact, there was one more model that was built that has used all the mathematical papers, all the research papers, and then it has to generate a small paragraph which is having equations, or it mimics the research paper. So it's not even making any sense. The result was not even making any sense, but it is at least mimicking and giving some equations and giving some mathematical related terminologies. People were really surprised in 2016, 17. I'm talking about, people were appreciating this a lot. In fact, I was one of that person. I was saying that, wow, this is wonderful. It is kind of giving mathematics related ones. It's not giving any random junk text. It is using the terminology that was used by Donald Trump. Like everybody was appreciating this, thinking that this is the best or state of art. But now, if you talk about large language models, now they give you all meaningful text. They generate code that runs, that they create content that makes sense. Even sophisticated question and answer. If you twist the question and try to get the answer, you will still get the right answer. The results are unbelievable. Suddenly, the whole industry kind of woke up, or it went to a shock for some time. Like the results of this ChatGPT large language models are too good. Nobody thought that there will be some tool that can beat Google, isn't it? Have you ever thought it? You have been using Google a lot. You think that Google is a day-to-day life. We have to use Google, isn't it? In our day-to-day. Have you ever thought that there will be one more model, or there will be one more website, there will be one more tool that will beat Google? No. But now we have something that can beat Google, isn't it? So let's go to the details of large language models. Some of the famous large language models as of today: Google's large language model is Gemini. Microsoft large language model is Copilot. The most widely used large language model is by OpenAI, ChatGPT. ChatGPT is the tool name or application name. The company name is OpenAI. People tend to call this large language model as OpenAI large language model. Like that, almost every big company have come up with their own large language model. Facebook, what is the large language model given by Facebook? Do you know what is the large language model given by Facebook by any chance? Anybody?
Sir, can we repeat the question? Sorry.
Facebook's large language model. So Google
Llama.
has given
Yes, sir.
Gemini,
Llama.
Llama, isn't it? OpenAI has given ChatGPT. So some of the, and all these large language models have been created quite recently only. We cannot say that they have been there from past 10 years or past 20 years or anything like that. So if you go back, maybe probably from 2022 onwards, like there were large language models, like the application was not that prominent in the industry. Industry was not paying any attention, or we are not really building production ready applications using those large language models during this time. We were just testing. GPT-1 was there, GPT-2 was there, GPT-3 onwards. That is when ChatGPT has released. GPT-3 is the backend engine, and then ChatGPT was released somewhere around this time, 2022. That is when this whole thing kind of blown up. Everybody kind of taken back, like the results that were given by ChatGPT. Everybody started using them. Very, very recent. It's not like it has been there from long back. Right now, the buzz is around OpenAI, ChatGPT, Gemini by Google, Copilot by Microsoft. Obviously, these are very big companies. Obviously, they will try to push their model. And there is one surprise package called Anthropic. As we are talking today, last week, there was one large language model that has been released, and it kind of overshadowed all these best of the best large language models that has been released by a Chinese company. Can you tell me what was the large language model that is right now in huge buzz? It just got released a couple of weeks back only, but everybody is talking about it because the benchmarks or because of the results that it is giving are quite good. So the large language model that got released
DeepSeek.
recently is
DeepSeek.
DeepSeek R model is what they are saying. Right now, people are still testing it. DeepSeek model, you never know. The best part about a DeepSeek model is that it is an open source, whereas OpenAI is not open source. If you are using too much, you will get an error saying that you have exceeded your free limit. All these are paid, but DeepSeek is open. Llama by Facebook is also open source, but maybe if we wait for a couple of months, DeepSeek becomes number one, or who knows, somebody else will come up with something else. This is too early. These are all are not perfect as of now. This is just we are just at the starting stage. Maybe in future there will be many more large language models that will be released. Right now, if you say this is the large language model, let's say OpenAI is this model is large language model ranked number one. Now you cannot expect it to be ranked number one forever. Within a week, within 2 weeks, this will be going down. Some other model will be ranked number one. Somebody will come up with new model. They will say this is number one. So right now, this is very, very early stage. You can look at a particular website called LLM Arena. On that, ranked number one models will be given here. Their ranking will be given. Now, this particular screenshot that you see, maybe this screenshot is 2 months old. 2 months back, O1 preview was one of the best one, ranked number one. ChatGPT 4o was ranked number two, O1 mini, and then Gemini 1.5 Pro is ranked number four. Now, if I open this, I may not see this one as number one. I may see some other model, totally a different model as number one, because you never know which model is making what type of improvement. Claude is here, GPT by OpenAI. So organizations that are leading are OpenAI, Google. What is XAI? Grok by Twitter,
Twitter.
Elon Musk. Yeah, XAI. These are the models. Like these were new entries actually. They were not there few months back. And then Meta Llama at top 5, 6, 7. They are there. Now, as I told you, you see, ranked number one is GPT 2.0. Right now, 1.5 was number four, but 2.0 Flash Thinking is coming as number one. Gemini EXP 1206 is number one again ranked. And then DeepSeek, you see that like that is too much, isn't it? DeepSeek within a week, it has reached number three position. It has surpassed Gemini and O1 preview. This is like too much, and you cannot really say that this Gemini will be there at that position forever. Maybe somebody, some other Chinese company, some other, maybe if Elon Musk thinks that he has to come up with a large language model, he can set up a team, he can put all that money, they can come up with even a better model, isn't it? You never know. So you have to look at this website to find out what are the most uh, technically strong large language models. But it doesn't matter like rank one whether you're using versus rank two. Maybe if you are looking at them for all the tasks, then it may matter. But if you ask me, will there be any huge difference between O1 or OpenAI versus Gemini in our results? We may not observe that huge results because something which is ranked number one versus rank number two, we may not see a huge difference. But yes, when somebody is saying that we have come up with a new model, everybody will question why should I use this model? Then they will try to look at some benchmarks, look at take some data sets, and then apply these. Like there will be some list of mathematics Olympiad questions. How O1 is performing in solving those questions. How DeepSeek is performing in solving those questions. How Gemini is performing in solving those questions. Then the ranking will be given. So these are some of the top ranked large language models. I'm just giving you an idea of large language models. We are going to get into prompt engineering. Prompt engineering is nothing but giving instruction to these large language models. It's good to get an idea on what are these large. It's good to get an idea on what is this ecosystem so that we feel comfortable. Otherwise, all this sounds very Greek and Latin. Like when people are talking about DeepSeek, what exactly is DeepSeek? Why everybody is talking about it? That much basic understanding we should have. That's why I'm talking about it. Okay. Now, there are two ways you can interact with large language models. One of the way is using the interface or the app provided by them. So for example, you have the ChatGPT. If I want to use ChatGPT, so this is one of the way I can use ChatGPT. I'll go to ChatGPT and I'll message here or I'll prompt here, whatever is the question that I have. Or I can go to Gemini. Now this is the interface that they have provided where I will be writing my questions, I will be getting the answers even Copilot. That is one way. The other way is if you are using these large language models inside a large application. Let's say you are building an application where the users will enter some question. You have an Android app where the user will enter the question and you have to give the answer to that question. Behind the scenes in Python code, you want to use large language model, then they will provide something called API. You can use them in API as well. So if you are using them as a developer, you will be using large language model API. Or if you are using them as a regular user, then you will be using these interfaces, these web browser provided by the large language model providers. So ChatGPT interface, we have used it. Gemini, maybe some of you must be using it. I think a lot of us are using ChatGPT. You can also use Gemini. Claude is a pretty good one. It is much faster. You can try this for sure. Copilot, anyway, they're trying to force us to use everywhere that we, like wherever we are using Microsoft applications. I think in future, Copilot will be automatically used inside that application. In future, it may happen. So how do we use large language model? So whatever we write here, that is known as a prompt. So whatever we are writing here, the message that you give to ChatGPT or the question that you're asking, it's not really called as a question, that is known as a prompt. So let's say my prompt is, according to neuroscience, what are the what are the 10 best ways to improve memory and concentration? Let's say this is a prompt that I have written. And then I will get the answer. Since I have asked for 10 best ways. So if you want to improve memory, you have to prioritize the sleep. It is almost like recharging our brain. Aim for 7 to 9 hours sleep, engage in regular physical exercise, practice mindful meditation, eat a brain healthy diet, etc. etc. These are the 10 tips. Now, probably a dietitian, probably somebody who has studied this would have given us all this. But right now we are asking ChatGPT, which will give us these values. And if I ask the same question, I may get similar answers to this. Physical exercise, quality of may not be exactly same order, but overall, healthy diet, stress management, learning new skills, memory techniques, etc., etc. These are the ways. Now, what is the use of these large language models in future? Whatever has been already documented in the internet, you may not need to remember or memorize that. For example, I do not know Python coding. Can I expect a assistant, an agent who is helping me with Python coding all the while? Yes, you can
That's
do
correct.
that. For example, if I have, let's say, let's go to Colab. A blank Colab is what we will open. New notebook. Imagine I have this bank market data. This is the data set that I have. Now I want to get this data set. I want to do some analysis on this data. But unfortunately, for me to do the analysis, I have to use Python code. I do not know how to write Python code. Then what is it saying? Start coding, or what is the next option? Generate with AI. So let me generate with AI. Import data from this location. This is the location that I have. This is a CSV file. Import data from this location. I do not know Python coding, but at least I know how to prompt. This is a prompt that I have given. And what is working behind the scenes in Colab, you can see Gemini is there. So I will just use that. It has given me the code. The most probably it will work. The prompt is what? The prompt is import data from this one, and it has given me a code that is importing the data from this particular location. All that you need to know is, like, a lot of people are kind of little scared of coding. Now you don't even need to learn coding. You just need to have clarity on what analysis you want to do. Let's say this is the data. I want to print all the column names. I just need to say the prompt print all the column names in the, what is the data set name? DF. This is the code for printing the column names. Probably multiple ways are there. So for call in column names, so this is not working. Usually, sometimes if it is not working, we tend to panic. Okay, what is the way to solve this problem? There are a couple of ways you can ask for explain the error. Otherwise, you can just re-ask it the same question. If it is giving the same output, I'll say explain the error. It is thinking. It has made some hypothesis why the error has come, and it has given a new code. So let me copy this code and try to paste the code here, the new piece of code. Let me execute that. See? What I'm trying to say here is, even if you get another error here, you can always ask it to explain the error. So what I'm trying to say here is, if you do not have coding background, if you're scared of coding, in future, we don't even need to write the code automatically, because there are thousands and thousands, not thousands, millions and billions of lines of code was already written that was fed into this Gemini model. That Gemini model has all the code information. If you ask the right question, non-ambiguously, without any ambiguity, if you ask any question, it must give you the answer. Let us suppose I want to ask a slightly difficult question. Create a bar chart. Create a bar chart for the column. What is the column name? Let's say bar chart makes sense for this column, maybe education, qualification, educational qualification. So it has given me some code. I'll execute it. If it works, well and good. If it doesn't work, then I have an option anyway. So it is working. This is the bar chart. Maybe I will ask another question. Create a histogram chart. All that I need to have is a clear idea in my mind. Create a histogram chart for the balance column. Here is the histogram chart for the balance column. In fact, even if you do not specifically ask generate the code, if you write as a comment and if you start typing, automatically the suggestions are given to you. Let's say if I want to create the histogram chart for age. Now this is just a comment that I have written. But if I wait for a couple of seconds, automatically the code is suggested. I'll hit tab. Automatically this code, most of the times this code works. Most of the times. So what I'm trying to say is these large language models, the results that they are giving are huge. Like earlier, if you ask a prompt, like I'm talking about maybe 8 or 9 years back when we were trying these language models for the first time, if you write a prompt that is related to Python, if it gives some gibberish or junk Python syntax also, people used to be very happy. See, I have asked a question in Python, it is giving me some random Python syntax. Look at this, my model is working perfect. Like people used to appreciate that. Even I myself was appreciating that you can see the question related to Python, the code is related to Python. It's not working. It is at least giving some code that is related to Python. That was the best state of art few years back. But now you ask the question, it will give you the code. If the code doesn't work, it has to correct the code also, and giving the results like this, taking our, like, these are all random text, isn't it? It's not like predefined questions. This is the text that was understood by the model, and it has given us the code perfectly to whatever the question that we are asking. The question that you see here is not known as question, that is known as a prompt. Now, our point of discussion is prompt engineering. Let's get into this topic of prompt engineering. But before getting there, I would like to take a couple of questions here. Let's pause here and take a couple of questions. Anybody having any questions?
Sir, I had a small question. Like, how do we know like the code that is written is like if it is there is no way to know, right? If it belongs to someone who has some rights over it, IP rights or some other thing, we will not know, right? Isn't that a risk? Like, okay, maybe not this one per se, but any of the code if we try to get.
So basically, the code that is suggested here has been given by large language model called Gemini. Okay.
Yeah.
We can say that we have generated this code from Gemini using Gemini.
Okay.
So the responsibility of using this code,
Hmm.
or whether we should use this code or not, whether this is copyrighted or not, that responsibility is taken care by Gemini. Okay.
Okay.
So we can use this code because it has been suggested by Gemini. It's not like we are copying or pasting from somewhere. Okay.
Okay.
It is generated from Gemini. Sometimes when the code is generated, you will
Hmm.
also get to see the link where it is using as reference. Let's say if I am trying to say bar chart. Sometimes when you are trying to print some of the, when you ask any question, it will give you from where it has got it. Most probably it will give you from the GitHub location where it has got this code. Let's say scatter plot for age versus balance. Let's say this is the plot that I wanted. And it is giving me this output, which means it is kind of generating on its own, or it is not really exactly copying or pasting from somewhere. Sometimes when this code is generated, you
Hmm.
will also get a link from where it got generated. Okay. As of now, what I would say is try to focus on the code part of it. The
Hmm.
rest of the, what is the privacy, what is the security, those are all secondary. Okay.
Okay.
Sir, as of now, can we make the complicated dashboards with it?
Yes. But it will not be from a single prompt. We may have to give a set of prompts, and then we may have to generate pieces of information inside a dashboard. Let's say inside this dashboard, if you're expecting 8 or 9 graphs, okay, or eight, like here there is some text, here there is one graph, there is one graph, like you have bits and pieces of information on this dashboard. Let's say there are 8 different items that you want to fill on this dashboard. Probably with a single prompt, you may not be able to fill all these 8 components. Maybe you have to generate them separately, and then you may have to stitch all of them together. So is large language model capable enough of building a dashboard? Yes, possible. But are there any tools that are sitting inside our tool or our application which is talking to large language model? Large language model will give you the result, or it will give you the code, or it will give you whatever is the result that is required. But is there, on top of it, we have to write another piece of code that can understand the output of a large language model and arrange like this. Is it capable? Yes. Are there any tools right now available? Yes. Are they available for free? No, they may not be.
Who is solution, sir?
Yeah. So in simple words, let's say you can create a dashboard using Python, isn't it? Can you get the Python code from a large language model? Can you get the Python code
Yes.
from large language model?
Yes,
Isn't it? You
sir.
can get it. So can I create a complicated dashboard? Yes. Using Python, I can create a complicated dashboard. How do I get the Python code? Using the large language model. But can it happen within single prompt? May not be. We have to get kind of chat by chat information or a couple of chats information, and then we have to ask large language model to export it either to a PDF or a markdown or an HTML. Then this dashboard will be given. Yeah.
Okay,
We have to give a proper, let's say, create. Let us try create a detailed dashboard using or interactive dashboard. Interactive dashboard with at least 4 graphs. Thinking. Let us see. It's trying plot 3, plot 4, and all those interactive. Education, if I take primary, education, balance range and education. Yeah, there will be some errors, but overall, you see that it's not that bad, isn't it? Is this the dashboard that you're also thinking? Something like this, whether a large language model can create or not? It is giving the basic version. We may have to write, like we can customize these kind of things. Like at least it has given us all this code. We have to make the modifications in this code to make this work. Let's say here it is taking education as one of the filter. Then you can ask further in the above dashboard, add some other column as a filter, maybe region as a filter. So this is a dashboard that it is using. Are you with me? Is it making sense?
yes,
As
sir.
of now, you can say this is kind of very basic. Maybe in future, we are going to see much more advanced version of all these. So that is just an introduction to large language model. Now let us go to part 2.
Continue with the next video in the playlist. We are covering everything step by step. If you have any questions or the comments, please post them in the comments window below.